Hello. In today's lesson, I'm going to teach you all some strategies that I like to use when I'm verifying trig identities or simplifying trig expressions. In the last lesson, we learned about all of these different identities, which I've compiled here for you on this handout. And I've added my top 8 strategies that I use when I solve these identities, because often students get kind of hung up. They say, I don't even know where to start. So hopefully this list will help you. So my first tip, you need to start with more complicated expressions. We talked about this last time. Next, use identities which lead you towards the other expression. So when I say that, I want you to be smart when choosing your identity. Don't just pick one because you remember it. Pick one that's going to lead you towards the other expression. Third, we're going to use Pythagorean identities when you have squares. So when you have expressions that have some trig function that is squared, you need to look at your Pythagorean identities. Now, I want to show you here, there are many variations or alternate forms to a lot of these identities. Specifically, the Pythagorean identities, you're going to want to, I added these to this list here, the alternate forms, which we get by simply algebraic manipulation, such as adding or subtracting one of the terms from one side to the other. And this is going to be helpful because sometimes this is going to better fit our problem. So maybe a tip if you want to remember with using Pythagorean, sine and cosines go together. Sine squareds and cosine squareds, excuse me, we'll do squareds go together. Secant squareds and tangent squareds go together. And then cosecant squareds and cotangent squareds go together. So this is just going to be helpful for you. Also, keep this sheet out with you at all times when you are working on these problems. All right, the fourth tip I have is to factor. So today I am going to dive in and show you an example in which we are factoring out a monomial. In pre-calc and in SAM, we do get into a little more complex factoring, in which it looks more like factoring of a trinomial. But why not get started now? Step 5, or strategy number 5, we're going to get a common denominator. I'm going to do an example of this today as well. Step 6, multiply by the conjugate. I'm going to save this one for pre-calc and SAM. However, it's a really good strategy to use. And if you are interested, you can send me an email. I'd be happy to go over this with you, provide you with some examples of that. Step 7, or strategy 7, split a fraction into 2 separate fractions. I'm going to show you how to do this today. And then the last resort, we can convert everything to sine and cosine. So when we do this converting of everything to sine and cosine, what we're really applying are those quotient identities there. So we'll dive right into an example. So our first example here says to prove the following trig identity using a Pythagorean identity. Okay, so we learned about our 3 Pythagorean identities in the last lesson. And in this case here, we are going to actually use one of those alternate forms to prove or to verify this trig identity. So I'm going to start with my complex side, which is the left-hand side. I see I have sine squared of x times cosine or cosecant squared of x minus 1 equals cosine squared x. Okay, so I do want to point out in this whole lesson, I did use my variable as x instead of theta, just to get you guys used to. Theta is not our only single variable that we're going to use with angles. It's very common. However, a couple of you guys had mentioned that it was difficult to type theta. So for ease of simplicity, we're going to use x in this. But sometimes we see alpha, sometimes we see beta, we see mu, we see lots of different variables to represent angle measurements. So for this whole case, I'm going to use x's. All right, but it's still just an angle measurement and a variable on that. So let's dive into it. So I see I have sine squared x times this quantity equals cosine squared x. So I see cosecant squared x. I am going to use one of my alternate forms of my trig identity to change that. So I'm going to continue kind of having the right-hand side with my little tools that I'm using to help me solve these. So I'm going to use Pythagorean identity. But I'm going to use the alternate form. So I am actually going to use the form. So just to show you where it actually was derived from before I do this, the Pythagorean identity, one of them is 1 plus cotangent squared x equals cosecant squared x. However, if I subtract 1 on both sides, I can have that alternate form, which is cotangent squared x equals cosecant squared x minus 1. And this matches what I have here. So I can now, remember it's an identity, so I can just interchange that with the other component. So that is going to simplify this to be sine squared x times cotangent squared x equals cosine squared x. All right, next step, I'm going to use my reciprocal identity. So remember, wait, actually, I'm going to use, excuse me, my quotient identity. Okay, yes, so I'm just going to use my quotient identity. Sorry, I called it reciprocal. So you can, so the thing, guys, there are variations on this, so we could do this in more than one way. So that's why I was thinking of a different way to do this. So sometimes when we're working through these, we have different ideas, but I'm going to stick with my original plan, which is to use that quotient identity. So I'm going to change cotangent now. So, or cotangent squared. So cotangent, remember, of x is cosine x over sine x. All right, and in this case here, although it is cotangent squared, remember we can just essentially pull that squared out of the cotangent in between the variable, and then it fits into our identities. So rewriting this now, swapping out that cotangent squared x for now, in this case, it'll be cosine squared x over sine squared x. Equals cosine squared x. Okay, now looking good from here, I could put a denominator of 1 under that sine squared x, but I kind of prefer to just cross out the numerators that match with the denominators. So I've got a sine squared x here. That's going to cancel out with that sine squared x down there, resulting in 1 times cosine squared x. And we are done. Cosine squared x equals cos squared x. Check. Beautiful. So our next example, we are going to be verifying this trig identity using the common denominator strategy. Actually, we use more than one strategy in all of these, but that's what I'm going to show you how to do. All right, so the first thing here, let's read our problem. Cosine of x times cotangent of x plus sine of x equals cosecant x. All right, so the left side is definitely more complex, so I'm going to start with that. Then I see I have cotangent in the middle. I'm going to use that, convert everything to sine and cosine to start, because I see I need to prove that the left side equals cosecant of x. And I remember the reciprocal identity that 1 over sine of x equals cosecant of x. So if I could simplify everything on the left to be 1 over sine, I think I'll be good. All right, so my first identity, like I said, I am going to swap out cotangent x. Remember, cotangent of x is equal to cosine x over sine of x. And that is a reciprocal. Nope, why do I keep calling it that? Quotient identity. Quotient identity. I won't name them. You have a list of them. You can read the names. I'll just name them identities like we did before. Alrighty. Okay, so I'm going to swap it out. So that leaves me with cosine x times cos x over sine x plus sine of x equals cosecant x. Beautiful. All right, so now I have cosine x times that whole fractional component. So I am going to multiply these together. So I can always set something over 1, and now I'm going to multiply numerator times numerator. So cos squared x over 1 times sine of x is just sine of x plus sine of x equals cosecant x. Okay. Next step I'm going to do is I am going to use that strategy. I cannot add a fraction with a whole number or a quantity, sine of x here, unless they have a common denominator. So in order to get them to have a common denominator, remember in algebra, we can always multiply any part of our expression or our equation by a quantity over itself, which is essentially multiplying by 1. So in this case here, what I'm going to do is just copy down this part again. So I need to multiply sine of x over 1 times sine of x over sine of x. Okay, this is where we are getting a common denominator. Okay, and that still equals cosecant x. Okay, all right, so now I'm just going to write this down again, cosine squared x over sine x plus, now I have sine x times sine x is sine squared x over 1 times sine x is sine x equals cosecant x. All right, so now that I have two fractions with a common denominator, I can add those together. Add their numerators together, excuse me. So I have cosine squared x plus sine squared x over sine of x equals cosecant x. Okay, now I see my Pythagorean identity there. So I know sine squared x plus cosine squared x equals 1, Pythagorean identity. So I am going to use that here. So I can rewrite this now, as I'm running out of room. 1 over, because cosine squared x plus sine squared x is 1 over sine of x, which is cosecant x. And then that is my reciprocal identity. 1 over sine of x is cosecant x. So from there, I have cosecant x. I ran out of room. But we do need to write that last final step where you have the same quantities on both sides of the equation. So I have cosecant x equals cosecant x. Check, I'm done. Now, in this next example, I will show you how we can use factoring to help solve a trig identity or simplify a trig expression, if we will. Okay, so before we even start, I just want to let's recall some simple facts about algebra. All right, so if I had the expression AB minus A, I can factor out the variable A. That is a shared component that is in both both terms. So I could factor this. So this is equal to a times b minus 1, okay? And I can, essentially this is reverse distribution. I think I've heard that expression before. But we're dividing out, or we're factoring out a common term. We've done this before many times. So now we're going to do this with our trig functions. It's totally, it's extremely helpful because often when we do this, we result in having some sort of a trig identity that we recognize that we can use. But as of right now, looking at this problem, sine x times cos squared x minus sine x equals negative sine cubed x. So right now I don't, look at this immediately and say, oh, I see a trig identity. I do see a squared in there. So I'm thinking maybe I can use one of my Pythagorean identities. But right now I can't. All right, so let's factor. So I see in both terms, I have sine x. I see I have sine x here and sine x here. So I can factor that out. Just as I factored a out of my other expression, I can factor sine of x out. All right, so I can factor out sine of x. So that would be sine of x times. So now sine of x divided out of the first term, sine x cos squared x, leaves me with cos squared x. Minus, now I have a sine x divided by sine x. Anything divided by itself is just 1 equals negative sine cubed x. Okay, all right, so there was my factoring. Now I see I have cos squared x minus 1. Well, this looks quite similar to a Pythagorean identity. Actually, it is an alternate form of the Pythagorean identity. So remember our Pythagorean identity, sine squared x plus cos squared x equals 1. Well, if I subtract, let's subtract sine squared x on both sides. Leaves me with cos squared x equals 1 minus sine squared x. Okay, but I need the 1 with the cos squared x. I'm going to subtract 1 on both sides. I have cosine squared x minus 1 equals negative sine squared x. Beautiful. All right, so now I am going to use negative sine squared x and substitute it in for that part of my equation. So sine x times negative sine squared x. Be careful here that you're not thinking this is subtraction. This is just multiplying by a negative. An alternate way we could have done it, I could have divided out or factored out negative sine x to begin with. So remember, there's not one unique way to solve these. This equals negative sine cubed x. All right, now I'm going to just multiply. So sine x times negative sine squared x is negative sine cubed x equals negative sine cubed x. Done. Easy peasy. Lemon squeezy. Our last example here, we'll be using the strategy in which we split a fraction into 2 separate fractions. So this is extremely helpful when we are working with an expression that has a binomial over a monomial. Okay, so we want a binomial over a monomial. Remember, binomial means it has 2 terms. Monomial means there is 1 term. So the left-hand side of my, my equality here, cosine x minus 1 over cosine squared x, that is a binomial, cosine x and 1, minus 1, over the monomial. Okay, so here I can split this into 2 separate fractions. So to split it into 2, I simply, this would simply split into cosine x over cosine squared x minus 1 over cosine squared x. All right, and this is all equal to secant x minus secant squared x. Okay, so for this specific problem, remember, I picked to begin working on the left-hand side. That looks more complex to me, but some people may choose to work on the right-hand side. But if you worked on the right-hand side, you wouldn't be using this strategy. So that's why I'm doing it the other way. Okay, great. Okay, so now I can cosine squared x. Oh yeah, and to check your work here, guys, you can always add these back together, add the fractions together, and see if you get that original expression. Alrighty, so what I can do here is I'm going to split. So cosine squared x is cosine x times cosine x. So cosine x over, I can split that into cosine x times cosine x. And I can also split or change the other side to 1 over cosine x squared. This is just going to allow me to actually apply some of our identities that we learned. Sometimes I skip the part where I take the squared out and I just work with things as if the identity holds true for squared values, but just be aware that this is the proper way to do it. We need to take that squared out, especially with that reciprocal identity there on the second one. All right, so now with the first part of my term, cosine x over cosine x, so I can just cross out. So my cosines there would divide out. That would leave me with 1 over cosine x. Okay, minus, now I have 1 over cosine x squared here. So we know our reciprocal identity, which says 1 over cosine x is secant x. All right, so I'm going to change what's within my brackets here to secant x squared. Then I am going to apply that same reciprocal identity again to the first term. So I can change, oh, and I need to put my equals secant x minus secant squared x. All right, so 1 over cosine x, we've got secant x minus secant, I can just move that squared right in, squared x equals the exact same expression. And we're done. All right, now you guys try the 4 examples that I have given you.